alternating current. It's hard to write on the screen this way. Alternating current. All right, what is the difference between electron flow and conventional? Isaac, can you forward to me what you did, and I will review on that. I can edit the text directly. I suppose I could. I suppose I could do that too. All right, so difference between electron flow and conventional. Yes, this is correct. Series and parallel. Okay, so it's not about a fail-safe path. There are multiple paths for electrons, allowing multiple loads on the same circuit. So, for example, in my home that I'm wiring, I am wiring a whole bunch of breakers on the same panel. That's a parallel circuit. So one wire comes into my home, providing electricity, actually 3 wires, but whatever. You know, one set of wires comes in providing power to my home, and I can put my upstairs lights, my downstairs lights, the dryer, the washer, the stove, the heater. I can put all of that on the same load. So that is a parallel circuit. It's not fail-safe like we do for aircraft, keeping things safe. It is multiple loads on the same circuit. Does that make sense? Okay. This I'd say is correct. Nothing, because there's no difference in voltage. That is correct. Zip, zap, zorp. I'm not sure what that's all about, but that's okay. Two batteries in series increases the voltage. Two batteries in parallel increases the time that voltage will be provided. Exactly. Adding more branches, yeah, because each branch gets the same amount of current, so you add the current from each branch too. So if I've got my battery here, let's see where's that. If I've got a battery and I come around here and I got resistor 1, I'll have 1 amp here, and then I'll put in here, and I'll have 1 amp there. Now I got 2 amps here. If I add a third one, I'll have 1 amp there, and I'll end up going to 3 amps. Okay. All right, so that little video series really excellent, and I highly recommend that you keep track of this for level 4, because when you get to level 4, you're going to go into all this stuff in way more depth. And I don't know what they got. I know they're good instructors, but this is a great series, and it will help you. Okay. What type of current does the transformer need to work? Alternating current, yes. Okay, we need alternating current. Why will the transformer not work with DC current? Because we have a stable magnetic field. And if the magnetic field doesn't change, we don't induce. Remember that magnetic induction. It needs motion. Oops. It needs motion or change. Or change in the fields. The wire's got to go through a magnetic field. The magnetic field has got to move next to the wire, or we need to have a changing magnetic field. Induction, perfect. What is a transformer core made out of? More specifically, laminated soft iron. But iron is correct. Laminated soft iron is corrector. There we go. Next question. Laminated sheets. Yes. Okay. Output winding will have more turns. Absolutely. Absolutely. The output winding has more turns. Compared to a battery, capacitor stores a small amount of charge, but charges and releases almost instantaneously. Perfect. Almost sounds like you were listening to me. What is inside a capacitor? Two conductive plates separated by dielectric is a fancy word. Dielectric, a fancy word for insulator. So it's an insulator, insulating material. Symbol for a capacitor. Just like so. Sometimes I've seen them like so, but I like the little curved line. That's the way I draw it. Real clear to me. All right. I've just been talking here. Any questions in what I've been going through? Or are you just furiously writing things down? Nothing yet? All right. How many magnetos are installed? 2, yes. How many do you need to run? 1. Well, Travis, yeah, we'll go over the T1A for sure. Travis, you should simply be editing your copy that you have already filled out. Oh, good. Good. Source of power for a magneto, rotating magnet. And what would happen if the battery died? You would not be able to watch a movie in flight. Correct. The in-flight entertainment system would die. But you would continue to fly. I think you got that right. What causes current to flow in the primary windings? The changing magnetic field from the rotating magnet, right? The changing magnetic flux from the rotating magnet, inducing current in the primary windings. All right. How do the breaker points affect magnetic field collapse? Breaker point shuts off the current, causing collapse of the primary coil magnetic field. Induces current in the secondary coils, creating higher voltage. Awesome. Very well written. Okay. A cam geared, this opens. What closes them? Ring. It's actually just a little spring. It's not a coiled spring, but it is a spring. Okay, when does the spark occur? Okay, this is not what we're after. That tells the spark where to go. When does the spark occur? What triggers the spark? When the breaker point's open. Opening the breaker points. E-gap doesn't cause the spark. E-gap is that particular spot where if we open the breaker points there, we'll get a really good spark. If we open the breaker points anywhere else, we won't get a really good spark. All right, which has more turns, primary or secondary coil? The secondary. Correct. Yes, to deaden the spark, so protect the points. And accelerate the field collapse. Yes. In parallel to the breaker points. Absolutely. How would the spark be affected if there was no capacitor? The breaker points would burn up, and we're talking about the spark at the spark plug. How would the spark at the spark plug be affected if there was no capacitor? It would be weak. The timing wouldn't change much. We're talking nanoseconds of change, but it would be a little bit later, but we're talking, microseconds. But it would be weak. That Joshua, are you asking why the timing wouldn't be off? I'm not sure what you're asking there, Josh. You were responding with a question. So it would be weaker because instead of a fast field collapse, we get a long, slower field collapse. And really what's happening is the energy is being dissipated in the breaker points instead of being forced out to the spark plug. So we get a weaker spark out at the spark plug and some of the spark in the magneto itself where we don't want it. And the timing, I suppose, would be off just a little bit. Are you happy there, Josh? Yes. Okay. How many terminals are there in distributor? 6. Well, sort of. More accurately, what would it be? What's the better answer than 6? Same as cylinders. Same as number of cylinders, right? Right. How is the magneto switched off? Grounding the primary circuit. Perfect. I'll give you a mark for that. Not that this is for marks, but 500. That's pretty slow. Let's say 600 to 700 idle. Most engines don't idle at 500 RPM. That's a really slow idle. 600 to 700 RPM is a normal idle speed. And this is the switch check. What's another name for this check? Live mag check. Okay, but Mertcan, there's two. There's the live mag check, which is this one. What's the other check? The magneto drop check is going to be on the next page. I think magneto drop check is the other one. That's one, the 50 RPM each magneto. The live mag check, we're testing the wires, the ignition wire, to make sure that the switch is doing its job. Does that make sense, Mertcan? Or anybody else? Kind of. Okay, remember there were two checks. One of them, we're checking to make sure that the magneto is performing properly. That's our magneto drop check. We drop from both magnetos to 1 to make sure that we get the right amount of drop. It should be 25 to 50 RPM. If it's more than or less than 25 to 50 RPM, there's something wrong. That's my magneto drop check. So that's where we do the both, right, left, and we point our switch to the right, to the both, or the left, and we should see 1600, 1550, 1555, right? The other one, we go to off, and it should, in that one, we're going to start at, oops, 700, and we should see it die. We just flip it over to off, and we should watch the engine die, and we're just going to catch it. We're going to flip it towards dying, and then we're going to quickly go back to both. That make sense, Mertcan? Yes. Yes. Why? He didn't say hi. Melting point. Where is the heat from a spark plug dissipated? No, it comes out to the cylinder head. Take a look at this picture here. Where does the heat go? It goes here. This is my cylinder head. Which is cold, and it's got fins and cooling air blowing over it. The heat goes out to the cylinder head. Have I got everybody there? The heat comes in from the nose core, comes out, and goes out into the cylinder head. All right. Back to here. Too cold, we get carbon deposits, and then they can glow. Too hot, the whole spark plug starts to glow. So those are both good good answers. It won't fit. You just can't. You're trying to put a 5/8 24 into a 3/4 20, you will not get them to fit. That make sense? Yep, half their original size. I would change that wording a little bit. Yes, external timing, timing relative to the engine. Yes, voltage will get lower and the spark will get weaker. The magneto is rotated on its mount to the engine. Very good. Is timing fixed? Okay, what is the timing on our engines? Anybody recall? Our timing is fixed. 25 degrees before top dead center, I believe. It's 25 or 22. It does not change. It should change. Every modern engine built today has variable timing. That little model airplane engine I've bought for you guys to learn on. I'm working on this thing. It has variable timing. You know, it's $400 for the whole engine, right? They all have variable timing except for our airplane engines. The one advantage of fixed timing is it is very simple, and not prone to breaking down. So I guess that's the advantage, but we should vary it, but we do not. Okay, what two problems is a magneto? Cranking speed, low voltage, and not backfire. What's the word we're looking for here? Nope. Timing is fixed. Yes, timing is fixed. It does not vary. It is adjustable, but it does not vary during engine operation. You're going to set it at 25 degrees before top dead center, and when you're running at 1,000 RPM, it's going to fire at 25. When you're running at 3,000 RPM, it's going to fire at 25 degrees. In my car, when I'm at idle, it fires at 8 degrees before top dead center. When I'm at engine at high cruise speed, it might fire at 40 degrees before top dead center. Okay, so here, what am I looking for? Not backfire. Backfire is when the fuel air mixture in the intake manifold catches fire and pops on us. We're looking for a different word here. Kickback. Not backfire, kickback. That's when you're spinning it clockwise and the fire gets in there and you're on the upstroke with the piston and it kicks back and it goes from running clockwise to running counterclockwise. And if you've ever had an engine kick back on you when you're manually starting it, it hurts like heck. All right, magneto, high tension, yes. Yes. AC. Primary electrical, secondary electrical, and magnetic. Okay, which of these are external on a low tension magneto? Yes. External on a low tension magneto. And so which are internal? The primary and the magnetic. Correct. Pole shoes, soft iron core, and rotating magnet. Hey, we're on page 6. We're almost on to page 7 out of 9. We're doing pretty well here, folks. Page 3. Perfect. Okay, and I am actually, just a sec here. I'm going to skip for a sec. Okay. I just want this one like so, and this one like so. Sorry, folks, I'm trying to move some stuff around here so I can see what I want to see. All right, so at E-gap, name all the things that should happen. Okay, what happens to the breaker points? This is something you want to make sure you know, all the things that happen at E-gap. What happens to the primary circuit? Is it closed or opened? It's opened, it's interrupted. The primary circuit is interrupted by opening the breaker points. All right, so we interrupt the primary circuit by opening the breaker points. What happens to the induced magnetic field? It collapses. What happens to the distributor finger? Where should it be pointing? Should be pointing at one of the pickups for one of the cylinders. When we're timing it, it should be pointing at number one spark plug lead. But as it goes through its rotation, it'll point at the correct cylinder. Yes. What happens to the capacitor? Does it charge or discharge? It charges, right? Where do we generate a spark? We generate the voltage in the secondary coil, and that spark goes out to the spark plug. All right, that's good to know. Okay, so I kind of modified this. I hope you were listening. Okay, where are compensated cams used? In radial engines. They don't need to be large or small. Just in radial engines. Other than that, this is correct. The elliptical path of those articulating connecting rods way back to week 1 of 1102. All right, what is the relationship between the numbering? So if I've got my cylinder like this, doot, 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 it's going to go 1, 6, 3, 2, 5, 4. That's our engine. But whatever the firing order of your engine is. Okay, and that seems to be pretty much what has been described here. Yeah, no, it doesn't need to be wet. Wet would be like cars will have problems with this, boats will have problems with this. When do we get flashover? Not to do with water, high altitude. Okay. Carbon tracking, those thin pencil-like lines of carbon. And then that cylinder doesn't fire. And worse yet, the wrong cylinder can fire. Good. Or pre-ignition. In another cylinder. Okay. They pressurize the magneto. Very good. Yes, absolutely. That wire mesh braid surrounds the length of the lead. We ground that out, prevents radiation escaping into the surrounding area, and Then we have this problem of the capacitance, so we put a resistor in the spark plug. Rotating magnet can be shared. What else? How about the cam? The input shaft? The case? What else? The rotating magnet? Anything else? I think that's it. And then duplicated is going to be points, coils, distributors, wires, plugs, and capacitors. Shared is going to be these ones. All right, how are we doing? You guys need me to pause for a sec here? Doing okay? All right. All right, what problems were designed to combat high voltage output and flashover at altitude, at high altitudes? Where are they found today? Typically found in cars, heavier, secondary coil voltage spark plug, yes. And I would agree with that. I already asked that. I already asked that. And we ask it again. Interesting. In a high tension system, one is needed per magneto, yes. In a low tension, one is needed for each spark plug. So if I had a 6-cylinder engine with a high tension, I'm going to have 2 coils. If I had a 6-cylinder engine, low tension, I would need 12 coils. And then to answer the question there on the test, so don't worry about that. Ooh, this is a trailing finger. And I don't know how I missed that. I think maybe I grabbed the wrong version of, oh, here we go. I missed one slide. Booster coil system. Booster coil system. This is old technology. Transport Canada required me to teach it. So I put a question on the test. This booster coil is powered, it's got internals much like the shower of sparks, but instead of retard points to delay the spark, we've got a trailing finger. So the engine is rotating here, this is rotating counterclockwise. This is the main finger. It's pointing at cylinder number 2. A little bit behind it is the trailing finger. So the booster coil is connected to the trailing finger. So the booster coil makes the spark hot. The trailing finger makes it late. All starting systems have the same goal in mind. Make a hot, late spark for starting. So you'll want to know about this trailing finger. All right, how does an impulse coupling? It uses a spring to charge it up, so it makes it fast, hot, and it makes it late by winding up, where it is installed on the input shaft. Or between the input shaft and the coupling. All right, I got people with me here. I think I'm doing all right. What is the source of power for the DC battery? What comes out? Low voltage, low pulsating. What comes out of the transformer coil, the ignition coil, is high voltage. Does that make sense? Do I need to show the diagram again? Here is my shower of sparks system, and I get low as in 28 volts going in here and coming out. I get a pulsed, but this is still 28 volts. It's DC because it's always going the same direction. Yeah, I can go over the shower of sparks again. Maybe what I'll do is I'm going to finish the sheet and then I'll come back and I'll do shower of sparks again. Because that one loses a lot of people. All right, let's finish this sheet. Because we're just about at the end, aren't we? Page 8 of 9. Okay, how is the retard points? And they conduct power away from the coil. And when they open, they stop conducting power away from the coil and force it through the coil. 1 light per magneto. Ding, ding, ding. Yes. What do they indicate? The exact moment the points open. Ding, ding, ding. They do not indicate when it closes. You can see that by watching them turn off. They're all methods of finding E gap. So this would be internal timing. Yes, they're all methods of finding. I like better than calibrating. On the compression stroke, yes, for cylinder number what? One, right. You could do it in theory on any cylinder, but all engines have cylinder number 1. So by convention, we always use 25 degrees before top dead center on the compression stroke, cylinder number 1. E gap position, correct. Terminal number 1. Right. Okay. What does it mean to say that the magnetos are synchronized? It means they operate in synchronized, firing the cylinders at precise times and at the same time. So the left magneto should send a spark at the same time as the right magneto. It's like when you watch a really nice synchronized dance troupe and all of their left legs come up at the same time. They're synchronized and all of them go down at the same time. They all go lift their right legs at the same time and their right legs go down. They're synchronized. Is it done for all magnetos? It is done for most magnetos. Some old engines use staggered timing. It's rare. You should be aware of it. You may come across it once in a while, and they'll fire the exhaust plug first. There's one of the plugs is closer to the exhaust, and they'll make you fire that one a little bit first. All right, this is the mag drop check. And you've done a great job in describing it. Reach specifies RPM, stabilize, place the ignition switch in the right position, note the RPM, then return to both, and then put it in the left, and you should see 25 to 50 RPM drop on each magneto. Okay. Wow, we're at the end here, aren't we? All right, air pressure increases electrical resistance. Exactly. Must make increased voltage. And if it's a weak system, we could have misfiring at high power. You'll find if your system is a bit weak when you're at full power, not at lower power. All right. How does it affect engine operation? Flashover more likely. Correct. And whether it does or doesn't, we don't know because we always throw them away. Very good. Round wire thickness gauge. Correct. What can happen if you are careless in your application of thread lubricant? You can permanently foul your plug. All right, these are mostly correct, so I'm moving along pretty fast here. It's almost 11. All right, if wear is noted on the breaker points, what's meant to be done? If it's simply from use, breaker points should be replaced. Sure. What's the other thing that could be causing my breaker point wear? If it was overuse, you'd replace. What's the other thing that can cause premature breaker point wear? Capacitor failed, right. If the cap failed, replace that too. Both. And in fact, we very often replace both anyway because capacitors are cheap, and so we do that. Okay, other than a review of the shower spark system, any particular questions? No, nothing? All right. Travis, sure. Kind of waiting for. Ooh. I wonder if I can erase this stuff. No, I can't. Hang on. Let's escape. There we go. That's better. I drew on my live sheet there. That's not good. The amount of. Well, we need know how. No, you don't need to figure that. That I showed you how we came to that, but you do not need to know how to calculate that. Kind of interesting to know, but don't stress yourself over that. From current slide. Okay, so for, gosh, I think this was Braden. We've got power. Do a pen. We've got power coming in. Goes through here. This is a parallel circuit. Two things we can do with our electricity. So some goes to the starter solenoid, which is a magnetic controlled switch, and it starts turning the propeller. So my propeller starts turning. Perfect. The rest of it goes this way. Comes here, sees a capacitor. That doesn't look like much fun. Look, some closed points. Let's go through the points. Round and round and round we go. What do we do when we go in a circle like that, Braden? What do we make? Nice, big, thick, green magnetic field. That was supposed to be green. Oh, wow. All right. And off we go. Do we get to do this for very long? No, why not? Because the magnetic field opens the points. And my points come open to this angle. Few electrons zip into here. Capacitor does its job, protects my points, and a little pulse of electricity made it through. Now the spring closes my points. They close back up, and we get this. And it sends another pulse, and then it opens, and another pulse, and another pulse, and another pulse. And it's going to send all these little pulses of DC power there. This is the starting vibrator. There's my primary coil. Have I got you there? This dotted line here, what is this? This is my left magneto. The starting vibrator is going to be installed somewhere else in the airplane, down in the belly. A couple of wires coming out of it. So what's coming out here is now pulsed DC power. How many volts is it? Actually, probably 24 volts because the engine's not running. I put in 24 volts. There's nothing to cause the voltage to increase. So what comes out of it is 24 volts in pulses. Does that make sense, Braden? Or have you zoned for 10 minutes accidentally again on me? You're dialed in. Okay, so do you see why I get 28 volts of pulsed DC? The electricity is always going positive to negative. It's always going the same way. That makes it direct current. And it is pulsed because it's turning on and off. I got you with me? So what would that pulsed DC do if we could force it through this coil? That's going to make it growing and then collapsing and then growing and then collapsing and then growing and then collapsing magnetic field, isn't it? 24 volts is coming from this battery here. So it's constant coming out of the battery. And 24 volts, most of our cars run on 12 volts. Most of our airplane batteries are 24 volts because we can use smaller wires. So just about any Cessna, Piper, Mooney, Beechcraft, whatever, is going to use a 24 volt battery. So the 24 volts goes in steady and then comes out pulsed. So that pulse DC, if we put it through here, we're going to get a changing magnetic field. That will induce here my sparks. So all I need to do is push that pulsed DC through the magneto or through the secondary coil, and I will get a shower of sparks. It'll wear out the spark plug really quick, but we don't care because we only run the system for 5 seconds. So we can't get a whole lot of wear when we just run it for 5 seconds. Each pulse, when it stops, will create a spark. The collapse of each pulse will create a spark, yes. And we're going to get hundreds of zaps a second. All right, so you with me? Each pulse is going to make a spark. Each one of these little zips will make its own little spark. So all I need to do is force them through my primary coil, make a nice thick magnetic field, and that will induce in my secondary coil a spark or a voltage, which will make a spark down in the spark plug. Okay, so now we need to time it. Now we've got a hot spark. Now we need to time it. So to time it, we're going to send this pulse DC is going to come along here, and it's going to come along here, right? There's pulse DC available all these places. Well, it's not going to want to go through here. It's really, really not going to want to go through there. But look at this. My advance points are closed, so it just goes through the ground until we turn to 25 degrees before top dead center. Then my advance points open, and this path goes away. So I can't send any electricity there. And then we turn to another 35 degrees. Now we're 10 degrees after top dead center. The piston is actually on the downstroke. Now these go away. Now my points are not an option. And reluctantly, my pulsed DC will now be forced through this coil and make a spark. Does that make sense, Braden? Those are the retard points, yes. And when we look at that double magneto that we've got in the shop, if you looked closely and were paying attention, one side had one set of points and the other side had two sets of points. And that was about the retard points. One of those sets of points is a retard point. They'll be set to open a little bit later, and they're built right in the magneto. Any other questions about this system? So that's why I'm saying the retard points and the advance points actually provide a path away from the coil. We don't force the electricity through the coil, we allow it to go away. Or we don't switch it. We don't have a switch that directs it to. We always provide the power, the option of going through the coil. It just doesn't want to. It goes through the coil when we open the points and it doesn't have a choice. It's that or don't go to ground, and the electricity really wants to go to ground, so it'll do that. Okay. I wanted to run through for a second here. Oh, there you are. Perfect. Okay, I just want to skim through. I'm actually going to skim through the test here, and I think I've got just about everything covered, but should make sure.